Welcome to my channel. This is Anil. So this is the first video on control system. So in this video I'm going to introduce block diagram reduction technique. So initially I'm going to speak some important rules related to block diagram reduction technique. So in this, the first rule is, so you see here three blocks, right? So blocks are connected in series. R is the input and X is the output. So between input and output, and blocks are connected in series, or you can also say it as cascade form. So you will take overall block diagram as in product form, G1 into G2 into G3. Between input and output, the overall block diagram relation is G1, G2, G3. So this is the first rule. Now coming to second rule is when blocks are connected in parallel. So G1, G2, G3. You can see, right, three blocks are connected in parallel. So in order to represent equivalent block diagram between input and output, you have to take sum. So I have G1 plus G2 plus G3. Now coming to third rule. So you can see here, right, this is known as takeoff point. So I want to shift this takeoff point after the block. After the block G, I want to represent this takeoff point. So what changes we are going to observe? So you see, right, in this forward path, I have R. Okay. So when I shift the takeoff point after the block, the result should be same, R. So you see here, I have R into G, but I want the result as R. So I am going to divide by 1 by G so that the final result will be R only. So remember that, so you have takeoff point, right? The takeoff point I am shifting after the block. So the changes I observe is we take 1 by G. Okay. Similarly, I have the takeoff point. The takeoff point I am shifting before the block. So what changes I am going to observe? So you see initially what I have, when I have the takeoff point here, I have the result as R into G. Now I shift in the takeoff point before the block. Then also I should get the same result, R into G. So I need to add a block G here. Only then I can get the result R into G. So do remember that we have the takeoff point here and we are shifting the takeoff point before the block. So when we shift the takeoff point before the block, we need to add block G. Okay. Now coming to next row, like takeoff point, we have no summing point. Okay. This summing point, I'm shifting after the block. So what changes we are going to observe? So if you see the output here, right, we have R plus S into G, R plus S into G. So when we shift the summing point after the block, then also the final answer should be same. So here you can see like R into G, right? So for S also we need to add block G. Only then the final answer will be same. So do remember that we have the summing point here. The summing point we are shifting after the block. Then we have to add additional block G. Now coming to next rule, we have the summing point here, right? That summing point I am shifting before the block. So when we shift the summing point before the block, we need to add additional block 1 by G. Explanation is same as last explanation. So do remember that suppose we have takeoff point here, right? The takeoff point, if I shift before the block, I have G here. When I have the summing point, when I shift before the block, I have 1 by G. Same thing here, I have summing point here that I shifted after the block, means G. When I have takeoff point, when I shifting after the block, I have 1 by G, means quite opposite. When you are shifting summing point, you have G. When you shift takeoff point, you have 1 by G. It makes easy for you to remember these 6 rules. So do remember that these 6 rules. The first rule is when blocks are in series, and the second rule is when blocks are in parallel, and third and fourth rule is related to takeoff point before the block and after the block, and fifth and sixth rules is related to summing point, shifting summing point before the block and after the block. Thank you.